Hello everyone and welcome to this presentation on structures in C. In this video, we will explore one of the most important features of C programming language, structures or structs. Structures allow us to group different types of data under a single name, making our code more organized and efficient, especially when working with complex data like records, coordinates, or objects. By the end of this video, you will understand what structures are, how to define and use them. Structure is a user-defined data type that enables us to store the collection of different data types. Means in C, a structure lets you group different types of data like integers, floats and arrays under one name. So this is different from array, which can only store elements of same type. The next point, each element of a structure is called a member. These individual variables inside the structures are called members. Each member can be of different type and can store separate values. Next, structures can simulate the use of classes and templates because it can store various information. So while C is not an object-oriented language, structure can mimic objects by grouping related data. You can think of it as a basic form of class without functions. The struct keyword is used to define the structure of a program. The keyword struct is used to declare a structure. You define the structure once and then you can create multiple variables of that structure type throughout your program. Let's take a look at the basic syntax for defining a structure in C. We start with the keyword struct, which tells the compiler that we are defining a structure. Next is the name of the structure, which is a user-defined identifier that is similar to naming a new data type. For example, we might call it a student, book, or employee. Inside the curly braces, we declare the members of the structure. These are the variables that belong to the structure. Each member can be of a different data type such as integer, float, character, and so on. Finally, don't forget the semicolon after the closing brace. It is required in C to end the structure definition. Let's now look at a real example of a structure. Here we have defined a structure named employee. We start with the keyword struct followed by the structure name, which is employee in this case. So inside the curly braces, we have three members. Int ID. This stores employee's ID number, which is an integer. Next, char name of 20. This is a character array that stores the employee's name up to 19 characters plus the null terminator. Next, float salary. This stores the employee's salary as a floating point number. Finally, we close the structure definition with semicolon. So this structure is now a blueprint. We can use it to create multiple employee records, each with its own ID, name, and salary. Before we jump deeper into structures, let's first understand why we need them. First, there are many cases where we need to store multiple attributes of a single entity. For example, consider a student. A student doesn't just have a name, they also have a roll number, age, marks, and maybe even an address. All of these are different pieces of information about the same object, the student. Second, it is not always true that all data for an entity is of the same type. A name is a string, age is an integer, a marks might be a float. So we can't just use an array or a single data type to store everything. So this is where structures come in. They allow us to group together different types of data under one unit. So think of a structure as a custom data type we create to represent real world entities that have multiple and mixed types of attributes. There are two ways we could handle this in C language. The first approach, construct individual arrays for storing names, roll numbers and marks. The second approach is use a special data structure to store the collection of different data types. Declaring structure variable. We can declare a variable for the structure so that we can access the member of the structure easily. There are two ways to declare the structure variable: by struct keyword within the main function and by declaring a variable at the time of defining the structure. Let us now look at syntax 1, where we define a structure first and then declare its variables later, typically inside the main function or another function. First, we use the keyword struct followed by a custom name. Here we use structure name. This is the blueprint that defines what kind of data the structure will hold. You can define members like int, char, float, etc. depending on your case. After the structure is defined, you create a structure variable using the same name. Here, var is a variable of the structure type, structure name. You can now use var.member1 or var.member2 and so on. Let's now look at syntax 2, which is another way to declare structure variables. This time directly along with the structure definition. The syntax is struct, structure name, open curly brace, member declaration, close the curly brace, then var1, var2. So they are structure variables. In this method, we define the structure and create variables at the same time. This approach is more compact and convenient if you don't need to use the structure elsewhere in the program, or you want to quickly create one or more structure variable without writing multiple lines. Here we can see how to access members of the structure. There are two ways to access structure members. The first one using dot operator or member operator, and the second one is using a structure pointer operator. This code defines a structure named employee. A structure is a user-defined data type in C that lets us group variables of different types together. The employee structure contains ID an integer to store employee ID, and name of 50, a character array to store employee's name up to 49 characters plus null terminator. And here, what is E1? It is a structure variable. It is declared immediately after defining the structure. This means you can now use E1.id and E1.name to store and access employee data. Let us see how we can store and access data using a structure variable in C. Here, E1.id is equal to 101. We assign the employee ID 101 to the ID member of the structure variable E1. Next line, strcpy E1.name, John within double quotes. So we use strcpy function to copy the string John into the character array name. We can't use equal to assign strings directly in C. Next comes printf statement. We use dot operator to access and print the structure members, and %d is used for integer to print the value of employee ID. %s is used for strings to print the value of employee name. E1.id is employee ID of ID member of the structure E1. Similarly, E1.name is employee name of the structure variable E1. Next comes basic structure operations. Copying structures. Copying is one of the most fundamental operations on structures in C. The assignment operator can be used to assign one structure variable to another, just as it is for fundamental data types. This operation creates a shallow copy, which implies that if the structure contains pointers to dynamically generated memory, only the pointer values are copied, not the memory content they refer to. If you want to replicate the dynamically allocated data, a deep copy must be created by allocating fresh memory and transferring the contents. This program demonstrates structure declaration, initialization, and assignment between structure variables. First, we can see structure definition. A struct emp is defined with the two members, emp ID of type integer and department of type char. This structure is used to represent an employee with ID and department code. Next comes main function. Here, struct emp E1 is equal to 1, D. 1 is the employee ID, D is the department code. Here, E1 is a variable of type struct emp. It is initialized directly with 1 for emp ID and D for department. Next, a new structure variable E2 is declared and assigned the value of E1. This means all member values from E1 are copied into E2. So in C, structure assignment is allowed as long as both variables are of same structure type. Next, we have two printf statements that prints the value of E2, employee ID as 1 and department as D. So the output of the program is E2, employee ID and department. This program helps you to understand how to define a structure, how to declare and initialize structure variables, how to copy structure values from one variable to another, and how to access and print structure members using dot operator. This content demonstrates the use of structures in C to group related data types like int and char. It shows how to define a structure using struct keyword, declare and initialize structure variables, assign one structure variable to another structure variable, that access structure members using dot operator, and finally print structure data using printer. So such use of structures helps in organizing and managing complex data efficiently in C programming. Thank you.